Ladies and gentlemen, as Piotr mentioned, the good side of this conference is that we can have speakers. That we can have speakers from from US, and we can have speakers from Japan talking about the Toyota production system, which is something I really enjoy. So if you haven't had a chance to listen to Kiro Harada before, then there will be recording, as Piotr mentioned. But also now we're getting into another keynote showing how to interpret what Toyota is doing. And the thing is, like over 10 years ago, I hope you can see it, I read this book, and it really, changed the way I was looking at the Toyota production system and understanding Toyota production system, but also about how do we make a software development and how do we copy the problems that Toyota was trying to solve with the system. So basically, how many ideas we can copy, not by copying the tools, but by copying the principles and some values they share. So what I've just learned from Professor Licker is that this book has a new edition after, I think, 15 years. So that's a good moment for having a new edition. There are more and more books by Professor Licker you can find in Polish, but there's also the new version of Toyota Way available in English. I'm gonna share some links on Slack soon. But before I do that, I would like to once again welcome very warm Jeff Licker from US, and the stage is yours.
Thank you. Thanks a lot, Thomas. So as Thomas was explaining, the Toyota Way is now in a second edition. So and there's a revision to the model, the original model. I'll talk about the difference, and I think this one is in fact broader. There's many more service examples. There's some software development examples, as well as a few examples from product development. I also have a second book that came out 2 years ago with one of my students, Jim Morgan, who led product development at Ford, and it's called Designing the Future, and that's about lean product process development. And in a lot of ways, I think lean product process development is a better model for software development than the Toyota production system, which was really designed for manufacturing. I'll also be talking about Toyota Kata, which was written by another student of mine, Mike Rother, and that's about how to develop the skills of scientific thinking, which is at the center of the new Toyota Way. And I'll be talking about Joy Incorporated by Richard Sheridan, which some of you may have heard about, but they have kind of a revolutionary way of developing software right here in Ann Arbor, Michigan, where I live. And it's very collaborative, and it actually follows the principles of the Toyota Way. But when the system was developed, Richard was not aware of the Toyota Way. He didn't know I was living in Ann Arbor. We've since connected and done a lot of work together. Okay, the new Toyota Way. First of all, the old one was a pyramid, and for the bottom level, the foundation, was about thinking long term and placing a high value on what the purpose of the company is. And the starting point for Toyota is serving society as well as serving specific customers of Toyota. Then the next level was processes, which are what we think of as lean, things like pull systems and one-piece flow. And then people are respected, challenged, and developed and in Toyota. And that one of the key skills expected of each person in the company is that they not only do their job, but they're also working every day to improve how they do their job through problem solving. So that was the model. And when I talked about problem solving, I was really talking about organizational learning. I've changed the pyramid into a circle with puzzle pieces to make it clear that it really is a system and every part of the system is connected. In the center, I put scientific thinking, and each of these 4 Ps depends upon scientific thinking to work effectively. And I've also changed the way I talk about each of the 4 Ps. So for example, I had talked about long-term thinking, but I've added systems thinking. And Toyota people seem to be natural systems thinkers, and there's a lot of Japan historic reasons for that. But when they just find the Toyota production system, they made it clear this is a house, it's a system. If any part of the house is not working, the whole house is weak and the system doesn't work. And what happens around the world, it seems to be particularly true in the West, is that people will pick up one part of the system, for example, just in time, and reducing lead time and introducing cells and maybe putting in a Kanban system, and they'll think they're doing the Toyota production system. Just in time is one element, one pillar, it's a key pillar, but that's accompanied by building in quality and surfacing problems every step of the way in the process. And then the foundation is to have stable, standardized processes for both you and your suppliers. And then at the center are people who are continuously improving, who have the skills and motivation to continuously improve. So just focusing on the tools of just in time is not by itself going to be very successful without the rest of the system. And similarly for the Toyota way, philosophy, process, people, and problem solving all need to work together. And it's hard, for example, to do this well if your philosophy is short-term. Our main concern is how we do this quarter, and our main customer base are our shareholders. We want to please them with our stock price. And that kind of a philosophy is not compatible with most of the other elements of the Toyota way. For processes, what I've emphasized is that we think of processes like one-piece flow, we think about Kanban, or we think about Agile, and we think about these as something, a thing to implement, as though it's a physical thing. Like you put, I think the Lean community and the Agile community has probably one of the biggest users of Post-it notes in the world. So we're great consumers of Post-it notes, but Post-it notes is not Agile, it's not Lean. What we're really trying to do is to strive for something that will make our software better, that will better please our customers, whatever that is. You need to define what that is. And then to achieve that process, for example, if the vision is that we want to provide software to the customer just in time with perfect quality within their budget, and in order to do that, we need to have a smooth flow of work throughout the project without interruption, without waste. That's what we're trying to achieve, not how well we write on Post-it notes. But using Post-it notes in the right way to visualize the process, where we are, where we need to be, can be a powerful step in the direction of trying to achieve the process we're striving for. I call that struggling to flow value to the customer, and that's kind of the key to the Toyota production system and Toyota's philosophy, is that they want to flow value to each customer successfully for that customer. And then in order to do that, and because Toyota thinks in terms of systems, and systems are complex, dynamic, they're feedback loops, and most importantly, we cannot predict the future. Toyota expects that the way they're going to learn how a process works is by running the process, by trying it, by doing it. And then when they run it, then they start to discover all the flaws. And the reason for discovering the flaws is not to be able to criticize people because they're screwing up. The reason for understanding the flaws is so you can, one by one, begin to solve these problems. And that requires people close to the problem, who are usually the people doing the work, identifying the problems and having the skills to solve the problems. And I call problem solving working scientifically toward a challenge. That will become clear as we go along. Okay, so what is scientific thinking? And I mentioned Mike Rother, that's Mike and me, and Mike was, again, a student of mine, and he wrote the book Terracotta, and he defined scientific thinking as the engine for continuous improvement. And it's a way of thinking and working, a practical way of thinking, working toward goals. It's a little bit different than a scientist in a laboratory who's trying to develop some generic solution for the world, like a vaccine. What we're trying to do mostly in our daily lives are solve the problems that we face in our daily life. And we all have goals of some kind or another. So he's thinking about scientific thinking as a practical way to work toward our goals, navigating through uncertain territory when we're not sure exactly what's going to happen between now and achieving our goals. And it has three elements. One is we have to acknowledge limits to what we know. So humbleness is really important for a good scientist. Second, we need to assume that the way we will find the answers will be by test, not simply theorizing. The theorizing can give you a vision. It can give you ideas to test, hypotheses, but then we have to run the experiment. And finally, we have to appreciate that when the experiment fails, we personally have not failed. And in fact, the difference between what we expect to happen and what happens is the best source of learning. I love this philosopher who defines scientific thinking in one character, which is a question mark. So scientific thinking really depends upon curiosity. We want to know, and we're looking forward to seeing the results of the experiment. Okay, so let's go to Toyota. And back in 2001, for the first time in its history, Toyota wrote down their way. Before that, they never talked about a way. And the purpose of doing this was to make the principles of the company explicit for overseas operations. They believed that the Toyota Way was the culture in Japan for Toyota, and almost everybody in Toyota Japan is hired right out of school. It could be high school, it could be college, and then they grow in the company and they retire from the company. So they're living the culture every day, and they're entering a very strong culture with leaders who all live the culture. So much so that it's hard. Was when I started to study them back in 1983, it was hard for them to explain to me what they were doing and why, because it seemed so obvious. You know, they could say things like, "No, you don't understand. It's really a way of thinking. It's not just tools," but they couldn't explain what they meant by that. And then they actually learned how to talk about it more from overseas operations, like their operations in America, where the Americans would learn from the Japanese, try it, struggle, and then they say, "Oh, this is what they meant." So they wrote it down in 2001 as another house. And in this house, the two pillars are continuous improvement and respect for people. Under continuous improvement, there's really three steps. One is you need to know your direction, which for Toyota, they want that to be a big challenge, not a small incremental step, but a breakthrough challenge. Now, and they want you to define that, agree on it, and it becomes usually part of a 3-year plan. And if it's a case of an organization like a factory, or for an individual, it becomes a 1-year plan. And then when you understand the direction, and it's a big enough challenge that they expect you don't know how to get there, then they want you to go and see and learn the current condition. Where am I now? What are our strengths? What are our weaknesses? What kind of problems do we have? And what's the gap between where we are and the challenge? So now we know where we want to go. We have bracketed the problem from the big picture, big challenge that seems almost impossible now, to where we are. And then the way you reach the challenge is through daily Kaizen. Do something every day to improve toward the challenge and to learn toward the challenge. This depends upon people who actually care about the company and care about the goals, care about the challenge. So that requires respect for people, which includes secure jobs, paying people well so they have a living wage, they can support their family, and also respecting them enough to invest in developing them, training them, and the level of development and training in Toyota is far beyond anything I've seen in other companies. And then at the center of Kaizen is teamwork as well as individual accountability. So on the one hand, you have teamwork and teams, whether it's cross-functional teams or work groups, perform the work and improve the work, but there's always an individual accountable for each project, for the annual plan, for achieving the goals, for achieving the key performance indicators. So it's that combination of individual accountability. And individual accountability does not mean I hold you accountable, do this, or you lose your job. Individual accountability means you need to feel responsible and take really seriously that this is your personal commitment. Okay, so the scope of the challenge is going to vary based on your level in the company. If you're at the top, these are transformational challenges like today, moving toward electrified vehicles, autonomous vehicles. That's led by executive vice presidents, Akio Toyoda's president, vice presidents in each country. So they have really big challenges to change the company in a way they've never have in the last 100 years. At the middle level, you'll have people, for example, who run factories, people who run IT in the US, people who run quality in the US, and they will have primarily operational goals, and they'll be leading big operational changes. And at the front line, you've got people who are doing the work, and on a daily basis, they're checking their work, they're looking at gaps between the goals and the reality, and they are making smaller incremental changes. So the continuous improvement in other words, doesn't mean small incremental changes. It means a challenge that's big, transformational even, but the way we achieve it is to do something every day, not to wait for a quarterly review and then kill yourself the night before the quarterly review. Just like as a professor, I retired 5 years ago, but as a professor, I wanted my students to be learning all the time, not waiting the night before the test. So this is actually what you could think of as scientific thinking: challenge, go and see to learn, and do your Kaizen. I have 14 principles, and I won't go through all these principles in detail, but let me just highlight what I mean by lean processes. And I mentioned struggle to flow value to each customer. And the question here is this something to implement or something to achieve? In the preface of the new book, I distinguish between a mechanistic view of organizations and an organic view of organizations, which is something that's been in the organizational design literature for the last 80 years at least. And in that distinction, you can either look at the organization like a machine with replaceable parts. The people actually become also replaceable parts. Or you can think about the organization as a living system that's dynamic, changing, evolving, and has to respond to a changing environment. And therefore, adaptability is highly valued. In looking at lean as a toolkit, like so many companies do, underlying that is a mechanistic view of the world. So a leader, it could be a chief executive officer, or it could be a chief operating officer, or it could be a plant manager, and they want to achieve specific goals. Usually the emphasis is on financial goals. And the tools they have at their disposal are key performance indicators, metrics, and then a carrot and a stick. And they hold the plant manager, say, accountable for achieving their objectives or else. And then they see that lean comes along and they learn somehow or another that companies that implement the tools of lean and make cells and put in Kanban are more productive and their costs go down, and they say, we want that. So now plant manager, install the Kanban system and get inventory down, set up cells and improve productivity. So the assumption is that these are something you can insert in the organization like a turbocharger on an engine and suddenly get greater horsepower. And the world simply doesn't work that way. And that was not the way Toyota thought about it. So again, like I said, they had a vision for the process, like value flows, there's no interruption, equipment works the way it's supposed to work, people understand their jobs and perform their jobs at a high level to the customer demand rate, which Toyota calls TACT. And we need to work to achieve that ideal vision, which is impossible to perfectly achieve. So we're constantly working to get closer and closer to the vision. And what one-piece flow actually does is surfaces problems so we can solve the problems and get closer to that vision. And what, for example, in physical inventory in a manufacturing plant, the more inventory I have, the more you're protected from me if I'm providing parts to you. And you can work off of inventory even when my machine breaks down. I don't have to worry too much about you, and I don't have to feel an urgency to get the machine running. But if there's not inventory, and if when I shut down, you shut down, everybody feels the urgency. And they want in Toyota people to feel an urgency, to be able to see we're behind, we have a problem, we have defects, we need to right now start working on it. And that's also the way Toyota uses visual management. In visual management for Toyota, they're always interested in what is the standard, what am I trying to achieve, what is the actual, and what's the gap. So you'll see in Toyota, red, yellow, green. Red, we're in trouble, we're far from the standard. Green, we're okay. And yellow, we seem to have a problem, but we seem to be getting it under control. So when you see people like this standing up in a meeting, which every level of the organization does every day, and they will look at where they are compared to their goals, to look at yesterday, and then what we need to do today to solve yesterday's problems. And all the leaders really are going to talk about are the red items. Where are the deviations from the standard? And then the group doesn't actually solve the problems in the meeting. It's just an information sharing meeting, and for people to get assignments, which they work on then outside of the meeting. And this visual management is used also for product development. This is a book a couple of years old now, but called Designing the Future, with Jim Morgan and other of my students. And Jim worked at Ford and was leading the transformation of Ford from near bankruptcy to quite profitable through all new vehicles, all new designs. Their quality went up, and a lot of that was driven by product development, not by manufacturing. So this is about that, plus a lot of other companies we've worked with as consultants to teach them lean product development. And one of the key tools is the big room, which in Japanese is Obeya. And it's really a collaborative visual project management room, kind of like you would have in Agile with your visual project management. And what it does is drives value, drives flow. So normally the Obeya was created to design the first Prius, which was a totally new technology for Toyota at the time. And they needed everybody in the room with expertise to develop the batteries and the electric motors and the switching circuits and all these new technologies. And the leader wanted a way to make decisions very quickly in real time and be able to visualize where there are problems. And in that case, they met every day in the room. That then became a standard for product development in Toyota. And most often they meet once a week. And when we set this up in other companies, we set it up for once a week meetings to check the pulse of each function within the product development group. So somebody's designing the body, somebody's designing the engine, somebody's designing the transmission. And what you see on the wall are cost, quality, timing, product features, suppliers, and where we are compared to where we need to be right now. And where there's red, and then what you need from other people to help you solve that problem. Okay. So problem solving is about acting scientifically to improve toward your desired future. You have to understand your direction and you have to have a strategy. So I added chapter 14, or principle 14 is new. And it's about linking strategy to execution. And 13 is also new. It's about something called Hoshin-Kanri, or policy deployment, which is having a strategy, having a 5-year plan, a 3-year plan, and then turning that into annual goals that are cascaded through the organization. And then I talk about problem solving as observing deeply and learning iteratively, and striving for continuous learning, which is, in Toyota's words, they draw on Deming's wheel, which is plan, do, check, act. And as I mentioned, there's a difference between mechanistic and organic. And in mechanistic, plan, do, check, act often means we analyze the heck out of the data, and then we try to determine precisely the root cause. And then we come up with an action plan. And then in the do, we put into practice the action plan. We check to confirm that we're right with our action plan. And then the act is to standardize what we came up with. Now, the assumption here is that in the plan stage, which is before we've actually tested anything, we already know what the solutions are. The action plan is a set of solutions with times and who's responsible for implementing them. And that's absolutely the wrong time to be locking yourself into solutions. So in the organic view of plan, do, check, act, which is really Deming's intention, the plan actually leads you to hypotheses. And then in Toyota's case, you take an idea, they call it a countermeasure, you prioritize them, and you try one, and you see what happens. And the do stage is really testing the hypothesis. The check stage is checking to see what happened, what are the facts, and then the act stage is reflecting on what we learned, which leads to the next experiment and the next experiment. So this all, I've talked to a lot of software development people, and I've worked with a lot of software development people, and I've never met one that doesn't relate to this, the idea of iterative learning, the idea of systems thinking, the idea of testing your ideas by trying them. That all seems to intuitively make sense to software developers. But we have one obstacle to doing this, to actually carrying it out, which is our brains. Our brains are the way we carry it out, but our brains actually limit us. And I won't go into a lot of detail about this, but if you go back to our evolutionary history, what was rewarded hundreds of thousands of years ago was not scientific thinking. What was rewarded was immediate action to kill the dangerous person or animal before they kill you, and bring food back to your family. So quick action, being decisive, and doing things right now to solve the immediate problem were at a premium, and people that were good at that were rewarded with children and spreading their genes. And people who were not good at that died off, and their genes didn't propagate. And when there was some sort of change in genes, some sort of random change in our brains, if that change favored doing and acting now over reflecting, then that became part of our gene pool that carried on. So for example, when we think about when we learn a new skill, we're intensively using a lot of energy in our brains, and we feel pained. Learning is actually painful, more so for some people than others. And that's because the pain centers are lighting up, and that was of evolutionary value back then. Those people who felt pain from thinking too much and wanted to do were rewarded through passing on their genes. So our natural inclination, and this varies with people, and there's certainly exceptions, and people with higher education, I suspect, are more likely to think scientifically and be a little more reflective, but most of us want to do and make it happen. And we want to assume we're right in what we think we know. Our brain takes in a huge amount of information, 11 million bits. The amount of information we're capable of taking in is incredible. We can only process 40 to 50 bits of information each section. So think about a funnel, this gigantic funnel of information with a tiny drip of information that we actually process with our conscious reasoning part of our brain. So we have to be very selective about what we process, and we have to add to that little bit of information through what become biases. For example, confirmation bias is based on a lot of experience that we have where we assume that this is the real problem, we assume this is the right answer, and we are biased toward finding data that supports our initial assumption. We try to prove that we're right. So how do we change our thinking? If we're not naturally good at scientific thinking and we need to somehow change the way we think, if we want to do this lean stuff that is associated with Toyota, how can we do that? And in Toyota's case, they have never lost the master-apprentice relationship, which was part of Japan for centuries and centuries before they industrialized. And it stayed with Toyota even to this day. They'll talk about people, for example, on the shop floor as craftsmen or craftspeople. And craftspeople need to be trained and developed by a master, a mentor. So in Toyota, every supervisor, every manager, every executive is also a mentor to coach the people who report to them and develop their skills. When they set up their first American plant in the United States, they sent over hundreds of Japanese so that every manager, every executive, and every supervisor had a personal trainer, a personal mentor. And they spent years developing the Americans till they finally felt comfortable leaving and then coming back periodically for additional coaching. That's what I mean by incredible investments. Hundreds of people, expats sent over just to train the Americans for years. So Mike rather realized that in other companies outside Toyota, they didn't have the will, the patience, or the skills, or the culture to develop people with that level of rigor, and it didn't come naturally. And in Japan, there's much less written down. It's much more just the craftsman knowledge through experience. So he wrote it down and he developed a very rigorous method. And it starts with the improvement kata model, which is very much like the Toyota Way 2001 model. What's your challenge? Number one, understand the current condition. Number two, what Mike added, which they don't explicitly talk about in Toyota, but they sort of do this, is you need to break down the challenge into small bite-sized pieces and then pick one, which is short term. So the challenge may be 6 months to a year out. And then you set your first target condition about 2 weeks out. So there's where I want to be in 2 weeks. I still am not sure exactly how to get there, but I have some ideas. And I'm going to test those ideas one by one by experimenting with them. When I achieve the target condition, I'll have a new current condition, and I'll set my next target condition. Sort of like if you're climbing a mountain, you wouldn't try to execute a plan to get to the top of the mountain. You'd have a vision, you'd have an initial plan, but then you might say, I want to get to that ridge. And you won't know exactly what obstacles will be between you and that ridge until they start to appear. Rocks start to fall, for example. So what we know and what we can implement without experimenting is within our knowledge threshold. And we can only see so far, like holding out a flashlight. And beyond what we know, beyond our threshold of knowledge, that's where we want to experiment. And as we experiment, we push out our threshold of knowledge, and we can see further and further until we get to the target condition, then the second target condition, and then finally to the goal. Mike developed practice routines. But by the way, the term kata, which I should have mentioned, comes from the martial arts, and Mike read about it in a book about the martial arts, and he was just absolutely amazed because it fit what he was trying to do so well, which is to break down a complex skill like karate into small specific skills, and then teaching each of those skills, which in Japanese are kata, teaching each kata one by one through the black belt, showing it to you, then you do it, then the black belt gives you corrective feedback, and you repeat it until it becomes natural, until it becomes a habit. So Mike developed kata for each of the 4 steps. That's in a book called the Toyota Kata Practice Guide. And he also included kata for the coach. Start by asking these questions. So the problem is that we have habits that perpetuate themselves. Once you do something a certain way, you're more likely to do it that way in the future. And once you develop like a subroutine in your brain, then that's what you're likely to draw on for a particular problem you face. And you won't think outside of that existing habit. So how do we break out of that pattern and start to become more scientific in our thinking? And that's where the starter kata comes in, by focusing on your behavior, behaving scientifically with a coach who's giving you feedback. And the more you address issues and pursue goals scientifically, the more that will become your new natural way of thinking. So let me just do a simple exercise just to practice learning a new skill. And the exercise is simply cross your arms. Please do this. Then uncross your arms. Then cross your arms. One interesting thing about crossing your arms is it seems to be universal across all cultures and ethnicities and geographical boundaries. So people somehow learn how to cross your arms. Now, you probably have practiced this most of your life, and you have a way of doing it that seems natural. Now try doing it the other way. Recross your arms so that the one that's on the bottom is on the top, and the one that's on the top is on the bottom. So it's like this. I'm not sure if I'm doing it right. And when we ask people how you feel about the second way, they'll say it feels awkward, slow, unnatural, uncomfortable, difficult. And I had to think about it. Remember that in our prehistoric heritage, we were punished for too much thinking because it was dangerous to our survival. So our brains are wired to punish us. You can actually see through CT scans that the red parts of the brain light up, which are the pain centers, when we think too much, when we're giving a task that requires learning something new and thinking too much. So what's happening here is that we practice folding our arms a certain way for our whole lives. We're good at it. It's natural. We don't have to think about it. And it's like a highway through our brain. And now trying it the other way is like trying to go through a forest that's undeveloped, and we don't know what we're going to face next. And it turns out every time you think or do something a certain way, you're more likely to do it again. And that's actually the problem with most training courses, is that we get a dose of how we should be doing something, like how we should be eating, how we should be exercising. And we start thinking about a new way to eat, a new way to exercise. And then we might do some exercise and practice a little bit. And then we go back to real life, and we naturally will revert to our old way. And every time we eat something unhealthy, or every day where we don't exercise, we are more likely then to do that again. So we're actually learning about one way of doing something, and what we're doing on a daily basis is the opposite way. And how we behave will always win out over what we think we want to do. The coaching process is aided by this storyboard, visual management. So each of these, the current condition, the target condition, a record of your experimenting, These are all laid out on this board, and the recommended time for coaching is about 10 to 20 minutes, and the recommended frequency is every day that the coach meet with the learner. Now, for that to happen, the coach really needs to be your supervisor, your boss, your manager. It can't be somebody from the Agile office or Lean office, because they don't have the bandwidth to coach everybody. So this starts to become part of your daily operation and your management hierarchy, rather than some staff-led thing coming from the side. Let me move to Menlo Innovations, which is this company in Ann Arbor, where I live. And I didn't know about them, and they didn't know about me for many years. But their starting point was Richard Sheridan, who worked in a medium-sized software development company. They were developing databases for healthcare, and he was the vice president of operations. And over the years, from when he was a student in computer science to when he started to practice and program to when he became a vice president, the joy of programming had been beaten out of him. It was no longer fun. It was just something to administer there. And he spent a lot of his time dealing with mad customers who were mad because their software was late, because it was buggy, because they didn't know how to use it. And he decided to dedicate his life to what Menlo believes, which is that software design and development should be a joyful experience. And to do that, he believed he needed to change everything. He needed to go from the mechanistic bureaucracy he was in to an organic, dynamic, collaborative, team-based experience where quality in software is built in at every step, and customers love the software you deliver. So that was his vision. And he had a partner, and they started this in that mechanistic old line company by doing an experiment. And they wanted to teach this new way of thinking that was based on extreme programming. And he had a consultant who was an expert on extreme programming. And that included working in pairs. It included breaking down the software into small features and then working on one feature at a time, checking the quality of that feature with a lot of engagement from customers every week. And he announced it to the group and was waiting to fight off the people who wanted to program in this new way, and not a single person signed up. They just wanted to do what they were doing, which is mostly in a cubicle in the dark, working by themselves on their programming, and then occasionally having a milestone review and discovering there's all sorts of problems with the software. So to change this, what he had to do is he had to bribe them. So at that point, Java was the new hot thing. So he said, we're going to work on using Java to develop software for the internet, but we're going to do it in this new way. And if you want to learn Java, you have to work in this new way. And when people started doing it, and he went down the basement, he got a few tables, and he got some Post-it notes, and that team loved it within weeks of working this way. As you can see, this is Menlo before COVID-19, and it's very collaborative. There's all sorts of information on the wall, lots of visual management, and it seems more like a big party than people developing software. He added a role called technical anthropologist, which is actually trademarked, and the technical anthropologist, usually he tried using software development people, IT people, and it didn't work. They weren't good at it. So he's found kindergarten teachers and journalists and social workers and a variety of people. It turns out mostly women seem to be better at it than men in the United States. And they actually go into the customer base and watch people use the software they have now and try to understand their strengths and weaknesses and needs by observing them in their native environment, finding their pain points, and being very empathetic and understanding what the users themselves may take for granted. You know, they're using several different spreadsheets and they're writing stuff down on paper, and they just think that's the way it needs to be. And they develop a mind map of their vision for the software system collaboratively with the customer, which is then the vision. And they actually have to have some drawing skills, and they have to mock up the user screens by drawing pictures. They often will make prototypes. If it's like a handheld device, they'll make a prototype of the handheld device. So they need arts and crafts skills as well. Then they develop a set of persona, which are fictitious people like the people they saw using the software. And they come up with pictures, and they come up with a story about that person. You can see it's handwritten. And one user might be the person who's, say, at the call center, who's answered the calls and using the software. And there might be a supervisor of that person, and there might be a tech support person. And they ask the customer to define the primary persona that's going to be in the center of this target. And that's the main person they're interested in pleasing. Now, what's interesting is most often the customer will put the manager in the center. And then after discussing it some more, they'll realize that the user really needs to be in the center. The tech anthropologist then creates story cards from each of those drawings they made of a user screen. So there's a drawing of a user screen, and it has different features. And for each button you push, for each thing you want to have happen, that becomes a feature. And they write down on a card the characteristics of that feature that they want the software developers to achieve. And that's based on their understanding of the customer. They write it down. It's not paperless. Now that's changed with COVID, as I'll explain in a second. And they want the description to be not what the programmer should do to program it, because these tech anthropologists don't understand programming necessarily, but what the outcome would be, what it should look like on the screen. They want it to be very simple, clear. There's not a lot of space to write this down. And when they write down a card, it's not authorized to be programmed. It's just potentially part of the scope of the project. They then estimate for each of these cards how long it would take to program it. And they can't use decimal points, but rather it's either 1 hour, 2 hours, 4 hours, 8 hours, 16 hours, or 32 hours, or even 64 hours. 32 hours would be 1 work week for Menlo. So you have pairs of programmers who are saying, yeah, this looks like it's about a 2-hour job. And they agree on that. And then the 3 pairs are evaluating the same card, and then they compare notes and they come up with a number. So now they now have a set of cards that are potentially the project scope. They know how long each one will take. And they meet with the customer and they play the project planning game. So this is their project management. And what happens here is that the project manager is meeting with the customer, and could be the tech anthropologist is there and whoever else is there. And they're showing the customer the potential scope as well as what this is going to cost you. What they do is they play what they call project origami. They fold paper. So a paper that's 4 hours is twice as tall as a paper that's 2 hours. And each paper is going to fit on a sheet, which is 6.5 hours of programming time. And each sheet is a day of work. They also use pairs of programmers for everything, and that's not optional. There's always going to be 2 people working on coding. So you're paying for 2 people for a day, and this is what it's going to cost you. And then you multiply that times the number of sheets, and you could say, here's what this is going to cost you for this project. Now, the customer may say, well, wait a second, that's way beyond my budget. I can't possibly afford that. And they'll say, don't worry. This is just potential. It's just various features that we agreed would be nice. Now let's pick the features that are essential to get within your budget. So they do that, and they come up with the actual project scope that they're willing to pay for, and then the other items are on the side. They can be added later, and it's very typical that the company will then stretch the budget and fund some of the additional features. You can see that same game being played virtually now with COVID. You can also see that once the customer agrees on the scope, then they actually have to play the cards, decide what to program week by week. And they come back once every week for a weekly review where they try the software that was programmed the previous week, and they decide on the project scope for the next week. The cards that they decide to play for the week are put on this project planning board. At the top are the names of the pair of people who are going to do the programming. And then you can see day by day, Wednesday through, in this case, Wednesday through Tuesday, each day, what they expect to program. Those are the story cards created by the tech anthropologist. They have a color coding system with sticky dots. So for example, if it's green, it's finished and ready to go. If it's red, it hasn't been started yet. And if it's yellow, they're working on it. And if it's orange, the quality advocate has come by and confirmed this works the way the customer expects, and it's ready to go. So a manager can walk by and there's a thread that you can't see well. The spread thread happens to be under Wednesday. So you'd expect by the end of the day, Wednesday, all these cards would be green, and they're not. So if you see a red card at the end of the day, Wednesday, then you know that we have a gap. Remember this idea of the gap between the standard and the actual? So you can see the gaps. And then those cards then need to be moved to the next day. And then when you meet with the customer, you'll explain where you didn't finish, and then you need to move those cards to the next week. So the actual scheduling is dynamic and changing week by week as the team learns and as the customer learns and thinks about different features and what their priorities are. You have an initial scope of work, but it's not executed as a project plan. It's still the scope of work that we intend, but we actually plan week by week based on what really happens. I mentioned that coding is done in pairs. That was back to extreme programming, and Menlo's religious about this. So you don't program, you don't write a line of code unless your partner's there with you. And with the partners doing, one person has the mouse and the partner is looking over their shoulder and pointing things out, and they're discussing them. And that's a way of building in quality. It's a way of enhancing creativity. And it's a way of keeping people very focused on the project. Because when they say they code for 6.5 hours, they code for 6.5 hours. It isn't an hour and then you get burned out, you take a walk around the block. They do have breaks scheduled, but by and large, people are really working hard and very, very intensely focused, and it really helps to have another person with you when you're doing that. The tech anthropologists work in pairs. The finance people work in pairs. Everybody works in pairs. The pairs rotate every week. So every week you're in a different pair. And nobody owns the equipment. You sit down at a desk that's open with a computer screen on it and keyboard, and you start to work on that project. And one of their philosophies is, we don't want any towers of knowledge. We don't want Jeff to be out this week and for the project to stop. So Jeff has been working with Mary, and Mary knows the project and has learned from Jeff the programming tool being used, and she can carry on when Jeff has moved to another pair or when Jeff is out sick or quits. What makes Menlo Menlo is teamwork, collaboration, trust, communication, relationships, empathy, and human energy. They get this not just by the way they manage, but also by selection. So one of Richard's famous quotes, and he has all these kind of clever quotes, one of his famous quotes is that a job interview is two people lying to each other. And they don't believe in job interviews. Resumes give you an idea that you have a living, breathing person. They got a degree, they have some programming knowledge, and that's a binary thing. Either they meet some minimum requirement or they don't. Once they're in the pool, then they come to a day that's scheduled for interviewing, maybe a dozen to 15 people at once. And what you do during the day is work on projects. And you're working in pairs, and Menlo people are wandering around observing how you work in pairs. And they're judging you by how you collaborate. And if you, for example, dominate, then you're not going to get hired no matter how technically skilled you are. As you can see, they also do factory tours, and they're very famous for their factory tours. They've had almost something like half the countries in the world have come to Menlo for a tour. They have courses, 1 day, 3 day, 1 week, and large companies like AT&T will send teams of people there to be trained in the Menlo way and bring it back to AT&T. Ford has been there, and they've and it's pretty amazing how this little tiny company has become a model like Toyota for emulating, for learning from. And you can do a online factory tour at this website. What Menlo's doing really fit the kata model for me, which was the challenge, which is what the tech anthropologists do, is the vision and the challenge, what we want to achieve with the software. Grasping the current conditions, the tech anthropologists study the users. They create these story cards. Each story card can be thought of as a target condition. We want to achieve what's on this card, but we don't know how to achieve it until the programmers put their heads together and start writing the code and seeing what happens. There's very rapid feedback. So Menlo is religious about unit tests. Every unit of code that you write needs to have a test to test it automatically. And then they run the test and it has to pass a test. And then they compile the software every day, and they find problems when they compile it overnight. And they're solving these problems and repairing the code as they do their work. Then the quality advocate comes along and says, does this meet the user needs or not? Yes or no. If yes, it's green. If no, it stays orange. And then we have to work on it until the quality advocate approves. That's happening every day. Or it might happen once we finish a story card. And so you have the immediate unit test, the test within the day by the quality advocate, and then the customer comes every week and tries out a week's worth of coding. So by the time you get to the last week, you only have 1 week of the last week of the project, you only have 1 week of coding to test. So the customer need is the target condition, and they're experimenting until they achieve that need. Again, it fits that model perfectly. That was not what they were aware of, Richard and his partner, when they developed this method. They were just trying to do a good job for the customer, make coding joyous, and also they're learning from extreme programming and later from the Agile Manifesto. So lessons learned is to start with a deep understanding of users. I think the tech anthropologists more deeply understand the users than most who set customer requirements. Break the big problem into a series of small problems. And this is also what Toyota does with their product development. Collaborate with your customers. Create a rhythm. Remember, you want one-piece flow. You want to flow value to the customer, and you want a pace to the work. And in an assembly line, the pace is the speed of the line. And there's no equivalent in software development. So they're creating a rhythm through the story cards, through the work authorization board, through the daily checks, through the weekly checks. Teamwork in pairs tend to beat individuals working in isolation, even if those individuals are technical geniuses. There are certainly cases where technical geniuses come up with a breakthrough and you don't really care how they work. Lean structure, even though it's a very structured environment, actually creates a very free environment for innovation. And that's sort of a paradox. So with that, I'll take questions.
Okay, thank you very much for this one. We had an interesting conversation about the visualization. So I'm going to start with those questions. Seems to be simple, but we still have a lot of challenges with visualizing the data. So the very first question is about if you know about the lean component after moving to virtual worlds due to COVID. How do they what tools they use in the remote environment?
Well, I'd flashed a few pictures, but everything they used was written because they're software developers. That became a project to develop the online version of the manual tools. And they ran it just like any other Menlo project with pairs of people working and with understanding their users. In that case, all the people working for Menlo were users, and setting a vision, and then breaking it down into story cards, and then working toward those story cards. So they had to do it very fast because COVID hit fast. But they had tried it in the past, and they tried automate or putting online most of their tools. So they already had a starting point. And every time in the past they tried it, they failed. It was never as good as the live version. So they would try it on a project, then within a few weeks they would just stop it and go back to the manual version. And I think the reason for that was because they could, because before COVID it was optional. So when they had a struggle point, they would just say, heck with this, I'll just go back to what we know how to do. With COVID, they didn't have the option. And therefore, when they faced a problem, they had to solve the problem, and they had to revise software. And they were able to get the online version working so well that even now, when they can work together, about half the people are actually working face-to-face, and about half the people are working remotely. They even have overseas people, like there's somebody who had been visiting from Russia, but when he went back to Russia, he was going to have to leave Menlo, but he's now still working for Menlo because he can use these tools, online tools. They have somebody who needed to go to Texas to be with a family member who was sick, and that person's working remotely, and it's no problem. So they've managed to achieve a pretty high level, much higher than they thought was possible virtually. But they had the foundation where they had worked out all the bugs manually first. And they think that was helpful to them. And they also still, when they can work face to face, they still prefer that. And they're finding some hybrid model as they're kind of coming out of COVID.
Yeah, I do prefer face-to-face work as well. The question was, before we get to Menlo Innovation, it was more about, you were showing Obeya in one of the companies. So it was less about the software development. I think I've seen Trello there for use by Menlo, but it's more about if you know what the like Toyota or other lean companies are using now for the Obeyas.
Okay, so I mentioned the mechanistic organic. So, for example, a mechanistic thinking company, which is actually, I think most companies, more than half, but I don't know for sure, I haven't done a study, but for managers that think in simple cause and effect, I do this, I get this result. Their thinking also is, I need to find the best of this, and thinking about like an independent variable. I need to find the best X to maximize Y. So for example, if I have an Obeya and Toyota uses the Obeya, and we believe, and we're trying to learn from Toyota, then I need the best design of an Obeya possible for my company. And then I need to make sure everybody follows that one best way. And if I go to India, if I go to Poland, if I go to the United States, I want to see the same Obeya, because that's the optimal Obeya. From an organic point of view, Toyota doesn't think that makes any sense. So they're saying the job of the product developer is to develop a great car that customers want, not to have the optimum Obeya that fits the company standards. So the concept of the Obeya is out there, and over time, everybody experiences it in some way. But Toyota has a role called a chief engineer, and every program has one person who's like the CEO of the business or like the founder of a startup company. And when they're creating, say, a plug-in hybrid, I have a plug-in hybrid sport utility vehicle, RAV4, and that was a new vehicle with new technology. The chief engineer for that, for my car, had a lot of control over how to develop the car and setting the vision for the car and understanding the customer, and is really the system integrator. So nobody's going to tell the chief engineer how to set up his Obeya. And if that chief engineer says, you know, I really think we could work more effectively if we have a virtual Obeya, nobody's going to say to the chief engineer, that's not the way we do it in Toyota. We always have manual Obeya. So there's some chief engineers that will develop a virtual version, have tried that. Some chief engineers have said, we need the management team meeting every week. Some chief engineers said, I need a huge room and I need all the key engineers working on this project in the one room together with me. And it's up to the chief engineer. How you arrange the information on the wall is up to you. You're going to have data on cost, quality, on timing, and on features, and you're going to have on suppliers for your particular parts that you're responsible for as an engineer. You're going to have all that data in your column, and it's the typical way of setting up the room is by column, part of the room, where body engineering is this column, and cost planning is this column, and transmission engineering is this column. And then you have a head of that function that is responsible for that part of the vehicle, and they will report out every week, and they will maintain their part of the wall. It's not set up by a staff person. But what you put in your column is up to you and your agreement with the chief engineer. So that's an organic approach. It evolves, and you have a lot of autonomy. The people doing the work and the people leading the front line who are doing the work have a lot of autonomy.
Cool. It's also worth mentioning that the chief engineer is also a technical person, which is not so common in other companies, right?
Yes. So there's usually not a role of a chief engineer. He has both business responsibility for meeting the business targets and the timing targets, as well as vision for the product and technical systems knowledge. And he can go around vetoing things, making final decisions on things, as well as coaching and mentoring. And the companies we work with, outside of Toyota, usually adopt the chief engineer model. And it takes years to develop those people and find those people. And they usually exist in the company if you can find them and develop them to play these two roles of project management and technical systems integrator.
Okay, I'm going to ask one more question regarding the visualization, because as I said, we had an interesting conversation on Slack about the visualization. And one of the observations people have is like, it's super difficult to visualize. It's like teams in software development are often reluctant to do the visualization. So the question is, any hints from your experience where to start when the companies move into the more visualization approach? What helps them?
Well, like I said, you don't need, if it's an imposed corporate standard, people will tend to resist. So my reaction, and particularly software programmers are very highly educated, intelligent people, and they've been responsible for themselves for many years. And if you come in and say, no, we're not doing it your way, we're doing it my way, and you need to do it, follow these rules, my natural tendency will be to say, okay, it's folding the arms. Okay, we'll do it your way. and then we'll see if it works. So prove to me you're right. But they're not bought in. So what you need to do is to collaborate with those people. And in Richard's case, he actually started, like I said, he started by externally motivating people through Reward, which is working on Java. But he found the initial team, and then they together came up with the work authorization board and the way to write out the story cards, and it became a team project. And then they were bought in, and they could adopt, they could modify it, as well as you had this executive, the vice president, who's coming down every day and working with them, paying attention to them. So a pilot like that is a good thing to do. And it's particularly good if you have people in the pilot who are opinion leaders, who others look up to. And then you go to the next group and the next group and the next group. So I would roll it out more by project group and then move it horizontally rather than top down where everybody has to follow the standard.
So the concept of deep and narrow over broad and shallow.
Exactly.
Okay, it's all after 5 p.m. here. I mean, I have a tons of questions to you, but basically it doesn't seem that I can ask them during this conference. So the next conference will be my questions only. Thank you very much for this conversation. Thank you. Thanks for joining us today. And I would like to thank anyone who is with us till 10 past 5 p.m. in Poland for joining us this year. As Piotr said, I hope we will see each other finally face-to-face next year. So finger crossed for this one, and enjoy your afternoon, and don't forget about the feedback after all the talks, especially after the keynotes. And if you want to spend some more time in Gather and have a few more conversations before you end up your day at the conference, feel free. Thank you very much.